In this video, we solve inequalities involving rational expressions. A rational expression is a fraction whose numerator and denominator are polynomials. The method of solving rational inequalities is quite different from the way we solve rational equations. Now let's look at some of the steps on how to solve them. So firstly, we will rearrange the inequality so that the rational expression is on the left-hand side, while 0 is on the right-hand side. And then we simplify the rational expression to form a single. Then we factorize both the numerator and denominator and then find their critical values. That is where the numerator and denominator are equal to 0. And then fourthly, we use the critical values to divide the number line into distinct intervals. And the fifth step is that we pick a number in each interval and test to see if they actually satisfy the inequality. And lastly, we write the intervals that satisfy the inequality. Now let's now see some examples to see how this can be done. So let's solve this. Solve x minus 3 over x plus 5 less than 4. Now the first step is to rearrange this inequality so that 0 is on the right hand side. And we do that by subtracting 4 from both sides. So we have x minus 3 over x plus 5 minus 4 less than 0. We subtracted 4 from both sides. And so we can do this. We simplify this further. We find the LCM of denominators. That gives us x plus 5. So x plus 5 into x plus 5, that's 1. 1 times x minus 3 gives us x minus 3 minus 1 into x plus 5 gives us x plus 5. X plus 5 times 4 gives us 4 into bracket x plus 5 less than 0. We can simplify the numerator further. We have x minus 3 minus 4 times x gives us minus 4x minus 4 times 5 gives us minus 20 over x plus 5 less than 0. Now x minus 4x gives us minus 3x, minus 3 minus 20 is minus 23 over x plus 5 less than 0. We now find the critical values of the numerator and the denominator. That is where both of them are equal to 0. So for the numerator, we have minus 3x minus 23 equals to 0. That implies that minus 3x equals to 23. That implies that x equals to minus 23 over 3, which is equals to minus 7 whole number 2 over 3. And then for the denominator, we have x plus 5 equals to 0. That implies that x equals to minus 5. So our critical values are minus 7 whole number 2 over 3 and minus 5. Now with our critical values, we now divide the number line into 3 distinct intervals. We start with the smaller critical value, minus 7 whole number 2 over 3, and then minus 5. So we have the first interval consists of numbers that are smaller than minus 7 whole number 2 over 3. The second interval consists of numbers between these two values. And then the third interval consists of numbers that are greater than minus 5. So we now pick a number in each interval and check if it satisfies this inequality. So for this first interval, I decide to pick minus 10. For the second interval, can pick let's pick minus 6, and the third interval we pick 0. So we test for each of them and see whether they are negative, whether this value is negative. Remember, we are looking for values of x where this expression is less than 0 or where this expression is negative. So let's test for minus 10. So we have minus 3, x is minus 10, minus 23 over x is minus 10 plus 5. Minus 3 times minus 10 gives us 30 minus 23 over minus 10 plus 5, that's minus 5. So I have 7 over minus 5, which is a negative number. So it is true in this interval. For this interval, it is true. We are looking for negative values. For the second interval, we test for minus 6. So we have minus 3. Where we have x, we put minus 6 minus 23 over x is minus 6 plus 5. This gives us 18 minus 23 over minus 6 plus 5 gives us minus 1. So 18 minus 23 is minus 5 over minus 1, which is equal to positive 5, which is false. Remember, we are looking for values that are negative, where it is less than 0, where it is negative. So it is false in this interval. For the last interval, we test for 0. So we have minus 3, 0 minus 23 over 0 plus 5. This gives us minus 23 over 5, which is a negative value. So it is also true in this interval. So this expression is negative when x is less than minus 7 whole number 2 over 3, and when x is greater than minus 5. And so the solution to our original inequality is x less than minus 7 whole number 2 over 3 and x greater than minus 5. Now let's see another example. Solve x squared minus 2x minus 15 over x minus 2 greater than or equal to 0. Now observe that 0 is already on the right hand side, so we do not need to arrange again. We only need to factorize the numerator. So we factorize the numerator. The constant term there is minus 15. So we look for two numbers that we multiply to give us minus 15, and when we add, gives us minus 2. So factors of minus 15, we have 1 and 15. We can have minus there. We also have 5 and 3. So if we put minus here, we have 3 minus 5 gives us minus 2, and 3 times minus 5 gives us minus 15. So I have x here, so I can have minus 5 here and plus 3 here over x minus 2 greater than or equal to 0. So we now find the critical values of the numerator. So for the numerator, I have x minus 5 equals to 0, implies that x equals to 5, and x plus 3 equals to 0 implies that x equals to minus 3. Now for the denominator, the critical values of the denominator, we equate the denominator to 0. X minus 2 equals to 0 implies that x equals to 2. So our critical values are, we arrange from the smallest value. So they are minus 3, 2, and 5. Now with our critical values, we can now divide the number line into distinct intervals. So we have minus 3 here, we can have 2 here, and then 5 here. So the three critical values divide the number line into 4 distinct intervals, the 1, 2, 3, 4. So we pick a number in each of the intervals and test whether they satisfy the inequality above. So for this interval, can pick minus 5. This interval will pick 0. For this interval, we pick 3. And for this interval, we can pick 6. So we pick each of these numbers and test in this expression to see if this expression will be greater than or equal to 0. That is where it will be positive. So we pick for the first interval, we pick -5. So I have -5, that's -10, -5 plus 3, that's -2, over -5 minus 2, that's -7. So I have -10 times -2, that's 20 over 7. That's -20 over 7, which is negative. So it is false in this interval. For this interval, we pick 0 and C. So we have 0 minus 5, that's -5, times 0 plus 3, that's 3, over 0 minus 2, that's -2. So we have a -15 over -2, which is 15 over 2, which is positive. So it is true in this interval. And then for this interval, we pick 3. 3 minus 5, that's -2, times 3 plus 3 gives us 6, over 3 minus 2, that's 1. So we have -12, which is negative in this interval. So it is false. Remember that we are looking for where it is positive or greater than or equal to 0. And then for this interval, we pick 6. So we have 6 minus 5 gives us 1, and 6 plus 3 gives us 9, over 6 minus 2 gives us 4. So we have 9 over 4, which is a positive value. So it is true in this interval. So the values of x that satisfy this inequality lie in this interval and this interval. So we have x is lying between -3 and 2. Observe that we cannot include 2, because if we put 2 for x in our denominator, we have 0, and we cannot, division by 0 is impossible. So to avoid dividing by 0, we exclude 2. So we have strictly less than, and x is greater than or equal to 5. So the solution to our original inequality is -3 less than or equal to x strictly less than 2, and x is greater than or equal to 5. Finally, let's see another example. Solve x minus 3 over x plus 4 is greater than or equal to x plus 2 over x minus 5. So we need to rearrange this so that 0 will be on the right hand side. We'll do that by subtracting this term from both sides of the inequality. And so we have this. We now have 0 on the right hand side. And then we find the LCM of the denominators. The LCM of the denominators are the product of these these two numbers. So we have x plus 4 into this gives us x minus 5. So we have x minus 5 times the numerator. We have x minus 5 times x minus 3 minus x minus 5 into this gives us x plus 4. So we have x plus 4 times x plus 2 is greater than or equal to 0. Now we can simplify the numerator now. X times x gives us x squared minus 3x minus 5x minus 5 times minus 3, that gives us plus 15 minus, let's open the bracket here, x squared minus plus 2x plus 4x plus 4 times 2 gives us 8 over x plus 4, x minus 5 is greater than or equal to 0. So we need to simplify the numerator further. We have x squared minus 3x minus 5x gives us minus 8x plus 15 minus x squared minus, this gives us 6x, and then minus 8 over x plus 4, x minus 5 is greater than or equal to 0. So This guy cancels this guy. We have minus 8x minus 6x, that's minus 14x. 15 minus 8 gives us plus 7 over x plus 4. X minus 5 is greater than or equal to 0. Now, we can now find the critical values of the numerator and the denominator. So, for the numerator, we have minus 14x plus 7 equals to 0, implies that minus 14x equals to minus 7. That implies that x equals to 7 over 14, which is 1 over 2. And then for the denominator, we have, if we quit this first factor to 0, we have x plus 4 equals to 0, implies that x equals to minus 4. And then x minus 5 equals to 0 implies that x equals to 5. So our critical values are, we arrange them from the smallest value, minus 4, 1 over 2, and 5. With the critical values, we can now draw our number line and divide the number line into intervals. So we start with minus 4, and then half, and 5. So these critical values divide the number line into distinct intervals, 1, 2, 3, 4. So we pick a number in each of the intervals. For this interval, I decide to pick minus 10. You can pick any suitable number in that interval. In this interval, you can pick 0. For this interval, I pick 1. And for the last interval, you can pick 10. We now find the values of x where this inequality is true. That is, where this expression is positive or equal to 0. So we test for minus 10 in this first interval. So if we have minus 10 here, we have 140 plus 7 over minus 10 plus 4 gives us minus 6 times minus 10 minus 5 gives us minus 15. So we have 147 over a positive value here. Minus times minus is plus. So we have a positive value in this interval. So this place is positive, which is true. And then for the second interval, we test the number 0. So we have minus 14 times 0 gives us 0, plus 1 over 0 plus 4 gives us 4, times 0 minus 5 gives us minus 5. So we have a positive value up and a negative value down, which gives us negative. Plus divided by minus is minus. So we have a negative value here, which is false. For this interval, we test 1. So minus 14 times 1 gives us minus 14, plus 7 over 1 plus 4 is 5, times 1 minus 5 is minus 4. So up here we have a negative value. 7 minus 14 is minus 7, which is negative, over denominator. Down here we have also a negative value. So negative divided by negative gives positive. So we have a positive value in this interval. So it is true in this interval. And then finally, in the last interval, we test for 10. So we have minus 14 times 10, that's minus 140, plus 7 over 10 plus 4 is 14 times 10 minus 5 is 5. So up here, we have a negative value over a positive value here, which gives negative. So it is false in this interval. So our inequality is true when x is, that is, when x is less than or equal to minus 4. And when x is also in this interval, that is, x is between and including 1 over 2 and 5. Also take note, like the previous example, that we cannot include 5, because if we put 5 in our denominator for x, if we put 5 for x here, we have 0. and division by 0 is undefined, so we cannot divide, so we exclude 5 from the interval. So the solution to our original inequality, the solution to this original inequality is x is less than or equals to -4 and 1/2 is less than or equal to x less than 5. This is the solution to this inequality. Thank you. I hope you enjoyed this video. If you do, like, share, and subscribe. Thank you.